Let's go ahead and get started on here so that way we can finish up. I think it might take most of the class, to be honest, to finish this review. How many valence electrons are in the following atoms? So how do we know the valence electrons? Well, I've got to go to the formula chart. When I look at the formula chart, I got to go see what group number electrons. Magnesium. Magnesium is a metal. He's in group 2, so he's going to have 2 valence electrons. Don't forget that little VE is valence electrons. Aluminum, group 13, 3 valence electrons. Argon. Argon is in group 18, 8 valence electrons. And then Na, sodium, 1 valence electron. So that's what they were trying to ask you there. The next one, number 2, says here, name the following polyatomic ions. Where are my polyatomics? Here they are at the top, just in case we're unfamiliar. Here they are. They want you to find NO3. So NO3 is over here. It's a -1 charge. That's nitrate. So that's the next one. C2H3O2, -1, acetate. OH, looking for OH, hydroxide. Okay. The next one, PO3, looking over here, PO3 with the -3, phosphite. Okay. So that's all they were asking from you. The next one here, write the formula for the compound formed from the following. All righty, well, we can do that. First thing is, I've got lithium and I got oxygen. I'm going to have a different color so that way I can get ready to crisscross. Why am I getting ready to crisscross? Because I have metals there. And if I have a metal, oxygen is a nonmetal which has a -2 charge, so I have to crisscross. When I crisscross those, that is going to be Li2O. Okay, Li2O. Let's keep going here. Aluminum is a metal that's in group 13, so a +3 charge. Sulfur is a nonmetal with a -2 charge. Crisscross those. When I crisscross them, they cannot reduce. Please don't forget to reduce. Al2S3. The next one, I've got potassium, +1, bromine, -1. Now, those can reduce, but, I mean, they're already reduced as far as they could. So it's going to be K, not P, Br. Hopefully not too bad, hopefully fairly simple, and we can do that. Let's keep going and practicing a little bit more because I want to make sure that there's no reason that this is not done. I want to make sure that we get it done. Magnesium is our next one. Magnesium is a +2, chlorine is a -1. Crisscross those. So MgCl2. Don't forget the second letter needs to be a lowercase. I'm going to skip down to letter H, lead. That is a Roman numeral 4, so that means it has a +4 charge. Oxygen is a nonmetal, which is a -2 charge. I got to crisscross them. Some of us are getting a little confused on the crisscrossing and reducing. So I'm going to say PB. PbO2. Put an X on that. So maybe if you go ahead and crisscross those numbers down and then reduce, but I do see some confusion and mistakes happening trying to reduce and crisscross at the same time. Okay. Next one here, chromium is a transition metal, and look at it. They actually gave you the charge at the top, and they didn't put it in Roman numeral numbers. It's the same thing, though. So they gave you the charge over there, which is a +2. Phosphate is a nonmetal. It has a -3 charge. So we're going to crisscross those. Cr3P2, because they cannot reduce. Something wrong here. What's wrong with ALN? Al is a metal, N is a nonmetal, so that's an ionic bond, and it must be reduced. So I'm going to put right here, reduce. And that's the problem. So it should be ALN, and we stop there. ALN, because we reduced those three to a 1. The next one here, magnesium and oxygen. Well, magnesium is a metal in group 2, so that's a +2 charge. Oxygen is a nonmetal, which is a -2 charge. If I crisscross those, it should look like this, MgO, and I had to reduce them. The next one over here, I have Cl chlorine, and I have Na. Go first. That's what the problem is. So I need to actually switch it. It should say NaCl. And I'm going to put NaCl. Na has a +1 charge. Cl is a -1. Crisscross them. NaCl is the correct answer. Okay. The next one here, hopefully we see what the problem is. That 32. Okay, we can't have two numbers like that. That's not going to happen. So something's going on. This is not an N and an O separate. It's actually a polyatomic, NO3. Magnesium is a metal that has a +2 charge. NO3 is going to have the charge of a -1 charge. Crisscross them. NO3, close parentheses 2. What are valence electrons? Valence electrons are the outermost electrons on an atom. And what makes them so special, as a quick reminder, is those are the ones that are doing the bonding. That's where all the reaction is coming from. And they, they'll do whatever it takes so that way they can have a full valence shell, which is the octet rule. In the electron configuration below, how many valence electrons does each atom have? Okay, so let's go ahead and look at this one. Well, they want to know valence electrons. This is before. This one is the last number of valence electrons left over. So how many? 1 valence electrons left over. What element is this? As a quick reminder, because there are a few questions like this on the test. If I go and get all of those little numbers at the top, 2, 2, 6, and 1, add them up. 6 plus 2 plus 2 is 10, plus 1 is 11. So I'm going to come over here. 11 is my magic number. Go to the periodic table, find out who is number 11 in A, sodium. So this means total number of electrons, which is also the atomic number. So if I add up all those little numbers, it's the total number of electrons, and our magic number was 11, which is also the same thing as the atomic number. So whose atomic number is 11? Na for sodium. Okay? Not too bad. It's been a while, and just in case if some of us forgot. So hopefully, I think you need to practice those two. Okay. The next one, number 7. When writing, it says here a formula, does the cation or anion always comes first? Now, I'm going to go ahead and first, I'm going to put metals or first. So is that the cation or is that the anion? Metals are going to be on the left side of the periodic table, and they are always going to have a positive. Okay, cation. To increase the stability of a metal cation should donate its electrons to an anion. Cations donate. Remember, when it comes to ionic bonding, transferring is occurring. I give you my electrons, you accept my electrons, but transferring is going to occur. The next one here, if magnesium and nitrogen form a compound, how many Mg's, ions, and how many N ions must be in each formula unit? So, for example, Al2O3 is a formula unit. That is one compound. How many aluminums are here? Magnesium in group 2, it has a +2 charge. N, who's over here in group 15, 1, 2, 3, a -3 charge. I need to crisscross them. Mg3N2. So I can say 3 magnesiums and 2 nitrogens. Those are the numbers. How did I solve for that? I went and found the charge number and I crisscrossed them, because for this formula unit, we're going to go back to formula units and moles pretty soon. That's our next unit. We're going to take it to another level. We need to have 3 Mg's and 2 nitrogens. That's what the metal plus non-metal. Ionic is going to be metal plus metal. Ionic is going to be metal plus polyatomic. Ionic is going to be polyatomic plus non-metal. Ionic is going to be poly plus poly. And that's 5 different ways that it can become that an ionic bond. Covalent is easy. Non-metal plus non-metal. So now that I have that information, now we're ready to go. Al2O3, ionic. CO2, covalent. Ki, ionic. AlOH3, next one, NO, N4O7, covalent. I messed up on one. Do you see the one I messed up on? Arsenic. Yeah, arsenic is not a metal. I mean, it's a poison, but it's not a metal. Yeah, that's covalent. For some reason, my brain always thinks arsenic's a metal. It's a non-metal. It's poisonous, but it's a non-metal. All right, so there's 2 more for you to do. I apologize for my mistake at the end. The next part here, determine the following descriptions if they're ionic, covalent, or metallic bonding. I know there are questions like that similar on. Bonding is stronger than covalent bonding. Letter C, which type occurs between, for an example, Ca and Cl or S in oxygen? So Ca and Cl, that's going to be covalent bonding. And then here they want to know, I don't know why they put or. S and O. S and O are also, this is covalent. It doesn't matter this one or this one, it's covalent bonding because they're all nonmetals, which occurs in alloys, metallic bonding. Okay? A metallic bonding is a solution of metals when they're melted together. It occurs when a cation donates is the key word, ionic bonding. And those are in our notes. I'm going to turn the page. Has the highest melting point, ionic bonding. Has the lowest melting point, I might be wrong. Yeah, no, covalent bonding. Good conductor of heat and electricity, metallic bonding. Okay? Oh, I like J. I think J is a test question. Form salt crystals in its solid phase, ionic bonding. Remember, covalent bonding can be a solid, liquid, or a gas at room temperature. Okay? There's a couple more for you to do. Letter I and letter K. Let's keep going. Next one. When drawing an electron dot structure of NaCl, what does each dot represent? So each dot, I'm going to put right here, the dots equals the valence electrons, not just the electrons. Don't use that word. It's valence electrons. And how would you show the transfer of electrons? With, I'm going to put a comma, and arrow. I'm going to also put in parentheses, or, and look at this, I'm just going to draw out brackets. And then it's going to have like the plus charge or whatever, but it has the little charge with it. So it's in our foldable. If you go back and look at the foldable. Number 13, what is the not obey the octet rule? In our note, there was actually only 2. So if you're thinking about it, man, Ms. Munson, you really only talked about 2. And that's true. I talked about 2. In our notes, there's 2. These are the 2 that we talked about. Boron and hydrogen. But there's one more. And it doesn't follow the octet rule. But then, Ms. Munson, if you haven't mentioned the 3rd one, how can you mention the 3rd one now? I just want us to think for a moment. And there was a 3rd one. You never mentioned it before. What is our notes over? Our notes have been over bonding, okay? But this one doesn't follow the octet rule with 8, but it's because he's already happy. Helium, okay? So he's also one that doesn't follow the octet rule, but his shell is already full, so he wasn't, if you notice, we never bonded him because he's already full. He's a noble gas. But truly, there are 3 elements that do not follow the octet rule, but helium doesn't do any bonding. Tossing it out there. And which bond, covalent or ionic, are electrons shared? Covalent. Transferred, ionic. In the molecule below, ooh, I like this one. How many lone pairs and shared pairs of electrons are there? Draw in the electrons if they are N and an S, 3 different elements bonded together. Now, hopefully we all agree that the H and the N can only have one line. Why is there a line? Because they're sharing, because hydrogen and nitrogen are both going to be nonmetals. Sulfur is a nonmetal also, so that's why all the lines are there. But hydrogen does not follow the octet rule because he can only have 2, and that line represents 2. So that means that hydrogen is done. Let's look at nitrogen. Here's one line right here, 2, 4, 6. Nitrogen must follow the octet rule, so that means that nitrogen must have a pair of lone electrons over here. So now nitrogen has 2, 4, 6, 8. 4, because each line represents 2. So the S needs more electrons. 4 is all he has. 5, 6, 7, 8. So when we drew in the electrons, if there's any lone pairs, there's 1, 2, 3. So how many lone pairs? There are 3 lone pairs, right? And how many shared pairs? 3 shared pairs. Hopefully that makes sense. I really like that drawing or that question. I thought that was a good question. All righty. Keep going. Which is the strongest between the single, double, or triple? Triple. And the blanks, fill in the blanks with this in the statements. A polar covalent bond is more electronegative atoms, has a slight negative charge. In general, the electronegativities of metals or nonmetals are greater than that of metals. In general, the electronegativities of metals or nonmetals are greater than that of metals. So who was the strongest electronegativity? Did my arrows go from up to top? Was it to right to left? Was it flossy fluorine? Was it Hercules helium? Was it francium? Who was my strongest electronegativity one? So Allie, who's that? Was it fluorine? Flossy fluorine is correct. So is it metals or non-metals now? Fluorine, is fluorine a metal or non-metal, Allie? Non-metal. Now, I want to make sure I stop for a moment. When we get to this question, here's the most important thing. There's a couple of math questions, like right here, that you're about to look on the test. What do you mean math questions? I really don't remember it. It's in our notes, and it really, we didn't cover it very math. Now, how do I find the electronegativity, or my objects can be, my compounds polar or non-polar? Number one, if I only have 2 elements bonding together, I can come over here, do the math subtraction, and come over here and find out if it's going to be non-polar, polar covalent, or just ionic. Okay? The other way is I can do the drawing, and if my Ca has lone pairs, it's automatically considered to be polar. Okay? If my Ca has no lone pairs, and I'm able to cut that sucker completely in half equally, symmetrically, then it's non-polar. Okay? I want to go real quick to that question, though. So there's 3 more questions right here for you to answer. Use the electronegativity charts in your notes. I promise you, I think there's 3 questions. 2.5, N is 3. One more time. I don't care about a negative. We need to find the difference. So in math class, the difference would be, okay, 3 take away 2.5, and that, if you feel a little better with that, 0.5 is my answer. Okay? Now the question here says, which bond is going to be the most polar? That means that I'm going to have to come over here and do all of them first to find out which one is the most polar. C and O. C is 2.5. O is 3.5. Subtract and find the difference. The answer is 1. H and F. F. So does this make sense? That's all you have to do. Pretty easy. Easy, easy. Find out which one has the biggest number. Okay? 19, 20, and 21. It says here on a separate sheet of paper, I'm sorry that I had to do this, but there was no other way to do it. Unless, and I'm going to toss this out there, unless you feel like you can do all of this in that little space, you are not hurting my heart by getting another piece of paper. I'm not sure how you're going to do your drawing, but maybe you're like, I really don't want to get another piece of paper, which I'm okay with. And you do H2O, I2, CO2, S, and I'm okay with that too. I mean, that would be pretty creative. So that way you can do your drawings on the side. You can write the shape. Over here, complete and the names. So they would like you to go ahead and name them over here. Well, we can do that. Not a problem. So let's do a couple just to make sure. We got PbCl4. Pb is lead. Cl4 is going to be chlorine. As a quick reminder, if it's ionic bond, you must cross. I don't care if you have to crisscross down or if you have to crisscross up. This is when we're going to have to crisscross up. Here is when we need to crisscross down. So that might be helpful. I'm going to put ionic, I'm going to put I, crisscross up. I'm going to put an I, and you're good to go. You don't even need me to say that. But this is where students make the mistakes. This 4 actually belongs to the Pb. The 1 belongs to the Cl. So to write out the name, I'm going to write lead, L-E-A-D, lead, Roman numerals 1B, and then I can write chloride. And again, if you don't want to put it on a separate paper and you feel like you can write small enough, this is perfect. Okay? Sn, selenium, and Br. Okay? Then we keep going. H, don't forget, if you have an H, that's an acid. H2O is not called water. H2O is going to be a covalent bond. That's when we have to have our prefixes. So dihydrogen oxide. That is the real name for water. Okay? So don't forget the acids. I see that there's only 2 acids. I'm going to circle them in green. Letter C and letter O. Okay? Don't forget, if it's a covalent bond, it needs to have the prefixes. Alrighty? Now let's come down over here to number 21. Number 121 again, if you feel like, no, I think I'm just going to go ahead and write it on here. Chromium 3 means crisscross down, and then in this case it's going to be Cr2 parentheses, because this 3 is going to cross down to my polyatomic, CO3 close parentheses 3. Okay? So hopefully not too bad. All right, other than that, this is the first time we ever got in here like with decent time and you're not like running or feeling like you're rushed. And I don't want you to feel rushed. I feel like I'm always rushed in this class and I apologize. So here we go. I did most of it with us, except for this last part. Choose whether you want to write it here or you want to write it on a separate piece of paper.